in the fucking job.
Hi guys, today I am introducing about displacement thickness. What is meant by displacement thickness? It is defined as the distance measured perpendicular to the boundary of the solid by which boundary should be displaced to compensate the reduction of flow on account of boundary layer formation. Due to the boundary layer formation, the velocity of the fluid on the boundary layer will be decreasing due to friction. Shear stressors are developed between the layers. That's why velocity is decreasing. Due to velocity is decreased, the rate of flow is also decreasing. To account the compensation of flow rate, we can displace the plate at a certain distance to compensate the rate of flow. It's called as displacement thickness. It is denoted by the letter delta star. This is the figure. Now fluid flows with capital U velocity. Now I can put the plate against the flow. Due to the I am putting the plate, the velocity of the fluid will decreasing and the form of boundary layer. Now I consider the 4 points A, B, C, D. When I consider a section CD, at C the velocity of the flow will be 0, at D the velocity is random. At the boundary layer the velocity is equal to the 0.99 times of velocity. This is the boundary layer formation. This is the velocity distribution. The velocity is parabolic. The velocity at C is 0, at increases parabolically. Now I consider the cross section of that longitudinal view. This is the cross section. Y is the distance from the plate when I consider the strip. Dy is the thickness of the strip. When U is the velocity of the fluid flowing through the strip. When B is the width of the plate. Area of the elementary strip. Mass flowing through the strip per second. How much fluid flowing through the strip flowing through the elementary strip with second, that is equal to when rho into velocity into area. Rho density of the fluid and velocity of the fluid and area of the section. Now rho into u, small u. Due to the formation of boundary layer, the velocity will be decreases. And dA, area of the elementary strip, and rho into small u into b into dy. This is the mass flowing per second through the strip. Now consider there is no plate. The velocity of the fluid is capital U. There is no plate, there is no boundary layer. The fluid flows freely. Mass of fluid flowing through the strip. Rho into velocity into area. Rho into, here velocity is equal to capital U. B into dy, area. Now reduction of mass through strip. How much mass will be reduction due to the formation of boundary layer? Now I consider. That's why equation 2 minus equation 1. Equation 2 is equal to rho into capital U into B into dy minus rho into small u into B into dy. Rho into u minus small u bracket of dy. This is the reduction of mass flowing through the strip. Now I want to find the total reduction of mass between the section CD. Total reduction of mass between the CD is obtaining by the integrating of this. Lead plate will be displaced at distance delta star. The velocity of the flow distance delta star will be capital U. Now loss of fluid flowing through the distance delta star, that is equal to rho into velocity into area. Rho into velocity is equal to capital U into B into delta star when area is equal to B into delta star. Now equating the two equations 3 and 4, now we get this equation, equating of those. Now cancelling the rho b on both sides. Now we can get the delta star is equal to integration of 0 to delta bracket of 1 minus small u by capital U bracket of dy. This is the final equation of displacement thickness equation. Thank you for watching.